Okay, let's give you guys some more practice. So here we've got a graph of this function. Work out the average value on the interval from 1 to 7. So work out the average value of this function from 1 to 7. Okay, so press pause and have a go. Okay, so to work out the average value from 1 to 7, we need to work out the area underneath the graph. So work out the whole area and then divide it by this length here, which happens to be 6. So really, to work out the average value from 1 to 7, what we're actually doing is we need to work out the area underneath this graph from 1 to 7 dx here, and then divide that by this length here, which happens to be 7 minus 1. Okay, so to work out the average value of this function from 1 to 7, we would need to do this. So the average value, would be us really evaluating this whole thing here. So this thing here becomes 1 over 6, and now it's just a matter of evaluating this now. So to evaluate this, your eyes should zoom into this complicated bit here, and then create your right angle triangle in such a way that this will be true. Okay, so your eyes should zoom into this bit here, create your right angle triangle. So if you make the hypotenuse to be x, the adjacent to be 1, then the opposite will have to be this complicated thing here. Okay, so to integrate this, your eyes should zoom into this bit here, and then create your right angle triangle in such a way that this will be true. So that will then give you this right angle triangle here. Once you've got your right angle triangle, then you can obtain your x here. So secant theta will be hypotenuse divided by the adjacent. So hypotenuse divided by the adjacent, which happens to be x. So secant theta will be x, and then differentiate both sides. So this will then become this, and then this will become this. So we've got dx equals this whole thing here. So later on we can put this into the dx, and then this complicated thing here, we can obtain this complicated thing here by looking at our right angle triangle. If you look at this, tan theta will be complicated over 1, which will be complicated here. So this complicated thing here is, well, we can put this tan theta into this complicated thing here. Okay, so now we need to sort out x. Well, if you look at this here, x is simply secant of theta, so we can put that into here, and then later on we will need to adjust our interval here, but we will sort that out later. Let's just concentrate on this bit here. So this whole thing here will then become this. Okay, so don't forget we will sort this out and this out later on. So let's just tidy this up first. So this will cancel out with this, and then here you've got 10 squared. So here you've got 10 squared. So now we need to sort out the interval. So earlier we integrated from 1 to 7 dx. So here, because we're in the d theta realm, we will need to make the adjustments here. Okay, so to make the adjustment, in the dx realm, we're integrating from 1 to 7. So in the d theta realm, because we made this substitution here, we need to make the adjustment. So when we're integrating from 1 to 7, so we're integrating from 1 all the way to 7, So we are really looking for secant of what gives us 1. Well, secant of 0 will give us 1. So to make our adjustment, it will be 0, and then we're looking for value here in such a way that when you secant it, it will then give you 7. Well, this interval here, so to make the adjustment here, it will then become this. Okay, So now we can integrate from 0 to whatever this value may be, inverse secant of 7. Okay, so we are integrating from here to here. So now it's just a matter of integrating tan squared. Well, to integrate tan squared, we've done this many times. Start out with this, divide everything by cos squared of theta. So that will then give you this, and then blah blah blah. We've done this many times. So to integrate tan squared, we would put this into the tan squared. Okay, so that will then give us this. That will then give us this here. So now this here is easy to integrate. Well, remember to integrate this. Just remember that when you differentiate tan theta, it will give you secant squared of theta. So if you want to integrate secant squared of theta, it will give you tan. Well, anyway, integrate this thing here, it will then give you this. So we are doing it from 0 to this value here, whatever this may be. So we are integrating it from 0 to this value here, and then now we can put it. We can then put this into here, and then put this into here, and then later on take away, put this into here, which happens to be 0. Put this into here, which happens to be 0. So we're going to minus 0 here. So we can pretty much forget about this. So now it's just well, when you put this into here, it becomes root 48 because of this. Look at this bit here. Create your right angle triangle here. So if you make this to be, so secant is this thing here, hypotenuse over adjacent. So well, if you make this to be 7, and this to be make the adjacent to be 1, then when you tan, so don't forget when you put this into here. So don't forget this angle here now, because we've set up our triangle here in such a way that this angle here is this block here. Hang on, this angle here, this angle here is hang on, this angle here is actually this number here. So this is our angle, whatever it may be. That's our angle here. This thing here is our angle, whatever it may be. So when you tan that thing there, when you tan this block here, it's really this thing over 1. So this length here, the opposite will be 49 take away 1, and then square root it. So that would be root 48. Yeah, root 48. So this length here is root 48. Badly explained. Let me just do this again. So if you set up your right angle triangle to be like this, 7 and this to be 1, then this length here must be root 48. So when you tan the angle, the angle here, it will be this, which is root 48 over 1, which is root 48. So badly explained, I hope you can follow it, but if you put this into here, it will become this, and then put this into here, it will then become this. So the average value within the interval from 1 to 7 is given by this. Okay, so this is your final answer.